Most people think cooking oil is stable as long as it's hot enough to cook food. But once oil starts smoking, the chemistry has already changed. And that change matters, not because it's immediately dangerous, but because it affects flavor, food quality, and what ends up on your plate. Let's put this in a familiar setting. Imagine a typical kitchen. A pan is heating on the stove. You pour in oil, maybe olive oil, maybe vegetable oil. You're in a bit of a hurry, so the heat goes a little higher than normal. The oil starts to shimmer, and then you notice a thin wisp of smoke. For most people, the response is simple. Keep cooking. You may be frying eggs, sautéing vegetables, or making a quick stir fry. Nothing bad happens right away. The food cooks, dinner gets made, and because nothing dramatic happens, it's easy to underestimate the changes happening at a chemical level. This is exactly why this cooking habit is so common and why it's worth understanding what's actually going on. Let's take a calm look at the chemistry. Cooking oils are made mostly of fats, which are long chains of carbon and hydrogen. Under normal conditions, these fats are stable, but when the temperature rises beyond a certain point, called the smoke point, the molecules start to break down. Here's what happens in stages. Stage 1. Oxidation. The fats react with oxygen in the air. This is called oxidation. Oxidation can produce tiny breakdown molecules. These molecules aren't instantly harmful, but they can irritate the eyes or throat and change the flavor of your food. Stage 2. Visible smoke. When the oil reaches its smoke point, you see smoke. This is more than steam. It contains compounds like acrylamide, which gives that sharp, acrid smell. Acrylamide is the same chemical that makes burnt oil smell unpleasant and can irritate your respiratory system. Stage 3. Decomposition of fats. As the oil stays heated beyond the smoke point, fat molecules continue to break down. Some small aldehydes form, and the oil starts to darken. These compounds are not dangerous in small amounts, but repeated overheating or multiple reuse can increase their concentration. Key takeaway: smoking oil is a chemical signal. It's a warning that the oil has reached its thermal limit. You don't need to panic. You do need to pay attention. Now let's separate myths from facts. Myth 1. Smoking oil is toxic and dangerous. Truth. The smoke is irritating, but occasional cooking with slightly overheated oil is not toxic. Your body can handle the tiny compounds formed in normal cooking. The key risk is only if oils are overheated repeatedly or consumed frequently at very high breakdown levels. Myth 2. All oils behave the same. Truth. Different oils have different smoke points. Olive oil and butter burn at relatively low temperatures. Avocado oil and refined vegetable oils can tolerate higher heat. Choosing the right oil for the heat you're using is smarter than avoiding cooking altogether. Myth 3. If you don't see smoke, everything is fine. Truth. Some chemical breakdown begins before smoke appears. Repeated heating increases oxidation and byproducts. So, visual cues are helpful, but awareness of the oil type and cooking temperature is better. Bottom line, chemistry is neutral. Smoking oil is not a disaster. It's a signal to adjust the heat, choose a better oil, or cook more mindfully. So what can you actually do in your kitchen? Match oil to heat, low to medium heat. Olive oil, butter, coconut oil. High heat avocado, refined sunflower, or peanut oil. Watch the oil. Shimmering equals sign hot. Ready to cook. Smoke equals sign reduce heat immediately. Avoid repeated reuse. Don't save oil that smells sharp, tastes bitter, or looks dark. Reused oil has more breakdown products and less stable fat molecules. Ventilate. Open a window or turn on a fan when oil smokes. This reduces irritation, not chemical harm. Trust your senses. Sight, smell, and taste are your kitchen chemistry detectors. If oil smells off, discard it. If food tastes bitter, it may be a chemical signal, not a health hazard. Cooking is about balance. Awareness, not fear, is the key to healthier and tastier meals. Let's put it in a human-friendly analogy. Think of oil like a person running on a treadmill. At a comfortable speed, everything is fine. Speed increases, the body starts to sweat and breathe faster. Too fast, exhaustion, strain, warning signs. Smoking oil is the kitchen equivalent of sweating. It's a signal that you have pushed past comfort. The body, or in this case, the oil, can handle occasional stress, but repeated extreme strain leads to breakdown. That's why paying attention matters. You're not poisoning yourself, you're just cooking more efficiently and safely. Morning eggs. Olive oil starts to smoke, reduce heat slightly. Eggs cook perfectly without bitterness. Vegetables stir fry. Avocado oil tolerates higher heat, crisp veggies, no smoke. Pan-fried chicken, butter alone burns quickly, mix with high smoke oil or cook on lower heat. Frying leftovers. Avoid reusing the oil multiple times. Flavor and chemical stability degrade with reuse. These examples show that small adjustments make a difference without changing your habits drastically. Cooking oil doesn't become dangerous. Suddenly, it reacts to heat in predictable ways. That's chemistry. Understanding these reactions helps you cook better, eat tastier, and stay calm in the kitchen. Good chemistry doesn't ask for fear. It asks for attention. So the next time your oil starts to shimmer or smoke, you'll know exactly what it means and how to respond wisely. Garlic and onions are the foundation of so many meals, but burn them and the flavor changes dramatically. That change isn't just a taste. It sets chemistry at work, and understanding it can make your cooking better without fear. Let's just imagine a familiar kitchen scene. You have decided to cook a simple dinner. A pan heats on the stove. A drizzle of oil goes in. You toss in some onions, maybe garlic too. The aroma starts to fill the kitchen. It smells inviting, comforting, but the heat is slightly higher than intended. Maybe you're distracted, scrolling through a recipe or multitasking. Suddenly, the onions start to darken quickly. The garlic turns sharp and bitter. Many home cooks shrug and continue cooking anyway. Dinner still gets made, but the flavor is noticeably off. This happens all the time, and most people just call it burnt and move on. But chemistry tells a deeper story. It's not just flavor, it's a signal of chemical changes in your food. Garlic and onions are packed with sulfur compounds. These are the chemicals responsible for their signature aroma and taste. When you cook them gently, the heat encourages mild chemical reactions. These reactions release sweetness and savory flavors. The result is a golden aromatic base for your meal. When the heat is too high, sulfur compounds start to break down differently. They form bitter, harsh compounds. These are chemically distinct from the savory molecules. Think of it this way. Cooking garlic and onions is like tuning a musical instrument. Gentle heat equals sign perfect pitch. Too much heat equals sign off-key notes. The result? Burnt garlic smells acrid, tastes sharp, and overpowers the dish. Interestingly, some of the molecules formed when garlic burns are also slightly irritating if inhaled. Not dangerous in your kitchen, but they explain that strong, unpleasant smell, and this is why the same pan, same ingredients, but different cooking heat can lead to very different meals. Let's tackle the myths around burnt garlic and onions. Myth 1: burnt garlic is toxic. Truth: burnt garlic is not dangerous. The compounds formed are safe in small amounts. They're just bitter and aromatic. The main effect is on flavor, not health. Myth 2: all cooking heat is the same. Truth: low heat encourages sweet, savory flavor. High heat can produce bitter, sulfur-rich compounds. Timing and temperature control are the chemistry keys, not luck. Myth 3: burnt smell equals sign chemical danger. Truth: that smell is a natural warning signal. It assists your nose saying flavor is off. That's not a sign of poisoning. Bottom line, burnt garlic changes the taste profile, not the safety of your food. It's chemistry in action, not chemistry gone wrong. So what can you do to avoid burning garlic and onions? Use lower heat when starting aromatics. Medium-low heat is usually enough to bring out sweetness and aroma. Add garlic later. Onions take longer to cook. Garlic can burn quickly if added too early. Add it after the onions are soft and translucent. Stir frequently, keeps ingredients from sticking, and ensures even cooking. Watch your pan. Aroma changes are signals. Sweet, nutty smells equal sign good. Sharp, acrid smells equal sign too hot. Lower the heat. Oil choice matters. Butter has a lower smoke point, burns faster. Olive oil or neutral oils tolerate slightly higher heat for onions and garlic. Remember, perfection is required. Small adjustments improve flavor and prevent overbitter compounds. It's about mindful cooking, not fear of chemicals. Let's simplify the science with a relatable analogy. Imagine sulfur compounds in garlic as tiny workers in a kitchen. At the right temperature, they prepare delicious flavors and aromas efficiently. Raise the heat too much, and the workers panic, creating unpleasant, bitter results. The compounds formed are still safe to eat. They're just chemically stressed, and that's reflected in taste and smell. Sautéing onions for pasta sauce. Use medium heat. Cook until soft and golden. Add garlic in the last one, 2 minutes for a balanced flavor. Stir-frying vegetables with garlic. Preheat the pan. Start with oil and vegetables first. Add garlic near the end to prevent burning. Garlic in butter for toast or eggs. Low heat only. Stir constantly to avoid bitter compounds forming. These small tweaks demonstrate that chemistry is predictable and adjusting your approach improves taste. Some people believe burnt garlic could give headaches or cause other health problems. Science says animal studies use far higher concentrations than what appears in a kitchen. In real-life cooking, burnt garlic is safe to eat, even if it tastes off. The risk is taste degradation, not toxicity. This is a perfect example of chemistry being neutral. It doesn't attack you. It just predictably changes compounds. If you want maximum flavor with minimal risk, use a combination of temperature control, timing, and oil choice. Understand that the smell is a signal. Embrace the chemistry rather than fear it. Cooking is an experiment you can manage. Burnt garlic is a failed experiment, not a toxic event. Garlic and onions teach us a simple lesson. Chemistry is at work in every pan. Burnt garlic is just dangerous. It's just a flavor signal guiding you toward better cooking. When you pay attention to temperature, timing, and aroma, you can cook confidently, safely, and deliciously. Remember, chemistry is your ally, not your enemy. Running meat smells amazing and adds incredible flavor, but when that browning turns black, the chemistry changes. Understanding what's happening lets you enjoy flavor without unnecessary chemical exposure. You're grilling or pan-searing your favorite cut of meat. The sizzle hits the pan. The aroma fills the kitchen or backyard. You love the golden brown crust. It smells savory, inviting, and delicious. But the heat is high. You keep the meat on the pan, enjoying the smell, checking the crust. Before you know it, parts of the meat are charred, almost black. Many people shrug and eat it anyway. The flavor is intense, even slightly bitter, but still satisfying. This is a common scene in kitchens and barbecues around the world. But chemically, things are shifting in the meat, and that's what we're exploring today. Meat contains proteins and fats, and when heated, these components undergo several chemical reactions. Proteins and sugars interact when heat is applied. This reaction creates browned crust, complex flavors, and the aroma we associate with delicious cooked meat. This happens at moderate heat and is what makes steaks, roasted chicken, and seared pork so appealing. Sugars in the meat or marinade break down and brown, add sweetness and color to the meat. When meat is exposed to extremely high heat for an extended period, especially when it turns black, additional reactions occur. Proteins and fats break down into compounds like HCAs, heterocyclic amines, and PHAs, polycyclic aromatic hydrocarbons. HCAs form from the amino acids in meat at high temperatures. PHAs form when fat drips onto heat sources, creating smoke that deposits on the surface of meat. Important perspective: occasional exposure is minimal. Eating grilled or seared meat once in a while does not automatically create a health problem. The concern arises only with frequent, repeated consumption of heavily charred meat over long periods. Let's separate fear from fact. Myth 1: any grilled meat is dangerous. Truth: light browning is completely safe. The Maillard reaction is flavor chemistry, not harmful. Only excessive charring increases HCAs and PAHs. Myth 2: the darker the crust, the more toxic. Truth: a golden brown crust is safe. Blackened bits contain higher levels of HCAs and PAHs, but occasional consumption is low risk. Myth 3: marinades don't matter. Truth: acidic or antioxidant-rich marinades like lemon juice, herbs, or garlic can reduce HCA formation. A simple marinade isn't just flavor. It also influences chemistry. Bottom line: grilling and searing are safe when done with awareness. Moderation, temperature control, and trimming charred edges are the keys. Here's how to enjoy grilled or seared meat safely. Aim for golden brown, not black. Sear the surface to develop flavor. Avoid prolonged exposure that creates blackened crusts. Trim heavily charred parts. If some edges blacken, trim them off. You still get the flavor without extra HCA-PHA exposure. Use indirect heat when grilling. Avoid placing meat directly over flames for long periods. Allows meat to cook evenly while reducing charring. Marinate when possible. Lemon vinegar, herbs, or garlic reduce HCA formation. Adds flavor and a chemical protective effect. Balance your diet. Eating grilled meat occasionally is fine. Combined with vegetables, whole grains, and antioxidant-rich foods. The goal: enjoy flavor, understand chemistry, avoid unnecessary extremes. Think of cooking meat like a musical performance. Moderate heat equals sign perfect harmony. High heat too long equals sign dissonance. The Maillard reaction is like a well-composed song. It makes the meat taste rich, savory, and layered. Charring is like playing the same note too loudly for too long. It's noticeable, perhaps unpleasant, and over time could create issues. The solution is like good music: timing, balance, and control. Backyard BBQ. Use medium heat. Flip steaks frequently. Avoid holding meat directly over flames for extended periods. Pan-seared chicken breast. Sear each side until golden. Finish cooking in the oven if needed. Golden crust plus fully cooked interior, minimal char. Marinated skewers. Soak meat in lemon, olive oil, and herbs. Grill with indirect heat. Flavorful and reduces chemical formation. These adjustments allow you to enjoy the delicious taste of grilled meat without unnecessary concern. Some claim grilled meat causes cancer or should be avoided entirely. Science perspective. Laboratory studies use high concentrations and repeated exposure over long periods. Occasional grilled meat, lightly browned, does not pose a measurable risk. Chemicals formed at extreme charring levels are not present in significant amounts in normal home cooking. This shows that chemistry is neutral. It creates flavor compounds and potentially problematic compounds only under extreme conditions. Understanding this allows you to make informed choices without fear. HCAs form mainly when protein is cooked at very high temperatures. PHAs appear primarily from smoke contact, such as fat dripping on flames. Vegetables and marinades rich in antioxidants can partially neutralize these compounds. Practical implication: adding vegetables to your grill or pan has both flavor and chemical protective effects. Grilling and searing are a perfect example of chemistry at work in your kitchen. The delicious brown crust comes from carefully balanced reactions. Occasional blackened bits? It's not ideal, but it's not catastrophic. By paying attention to heat, timing, and marinades, you can enjoy grilled meat safely and deliciously. Remember, chemistry is your cooking ally, not your enemy. Cooking oil doesn't reset after you use it. Once it breaks down, it stays broken down. Understanding this simple chemistry helps you cook smarter, not fearfully. Think about a busy kitchen. You fry food. There's just leftover oil in the pan. It looks fine. It feels wasteful to throw it away. So you pour it into a container, hoping to use it later. Maybe for another meal tonight, or even tomorrow. Nothing seems wrong. Dinner turns out fine. Many people do this every day. It's practical, economical, and convenient. But chemistry is quietly changing that oil. It's not dangerous in a dramatic sense, but the properties of the oil shift, and that affects flavor, stability, and long-term quality. Cooking oils are mostly triglycerides, which are molecules made of fats. When you heat oil once, some triglycerides oxidize, minor breakdown products form. Flavor and aroma may remain mostly the same. When you reuse oil, these changes increase. Step 1. Oxidation. Heat plus oxygen break down fats into smaller molecules. These molecules can have bitter or off flavors. Step 2. Polymerization. Fat molecules combine into larger chains. This makes oil thicker and darker. Step 3. Formation of aldehydes and free radicals. Longer reheating cycles increase these small reactive compounds, not immediately dangerous, but can irritate the senses and affect food quality. Think of the oil like a sponge. Fresh oil absorbs flavors well and cooks evenly. Reused oil is chemically tired, darker, and more reactive. Even though it's still technically edible, its chemistry has shifted. Myth 1. Reusing oil once is dangerous. Truth. Occasional reuse of oil is safe. The chemical changes are minor after a single use. Myth 2. All reused oil is toxic. Truth. Only oil that has been repeatedly overheated and stored improperly accumulates significant breakdown products. Proper handling reduces negative effects. Myth 3. Oil that looks clear is safe forever. Truth. Oil can look fine, but develop off flavors and minor chemical changes. Smell, color, and consistency are the best indicators. Bottom line, chemistry changes with heat, but moderate reuse is safe. Repeated, prolonged reheating or using burnt oil is where problems grow. Here's that's what to do in everyday cooking. Limit reuse. Using oil once or twice is generally okay. Beyond that, chemical breakdown becomes more significant. Discard if off. Oil that smells acrid, tastes bitter, or is dark and thick should be thrown away. Store properly. Cool the oil to room temperature. Keep in an airtight container away from light. Avoid high heat repeated frying. Each reheating cycle accelerates oxidation. Avoid using the same oil for deep frying multiple times in one session. Trust your senses. Sight, smell, and taste are your chemical detectors in the kitchen. Following these tips keeps your food flavorful and avoids unnecessary chemical changes without fear. Imagine oil like a battery. Fresh oil, equal sign, fully charged, ready to perform. Heated once equal sign, slightly drained, still works well. Heated multiple times equal sign, less stable, weaker performance. Cooking with oil is similar. You can use it efficiently, but overuse leads to decreased quality. This doesn't mean danger. It's simply a chemical reality. Understanding it helps you cook smarter, not fearfully. Single use, stir fry. Oil is used once for vegetables. Flavored preserve, chemistry mostly unchanged. Reusing oil for another meal. Safe if stored correctly and used soon after. Smell and color remain good. Deep frying multiple times in the same oil darkens. Bitter taste develops. Small chemical changes accumulate, affecting both flavor and stability. By adjusting your habits, you can maximize efficiency while minimizing chemical degradation. Some people claim reused oil is toxic and will cause long-term health issues. Science perspective, minor chemical changes are expected. Toxicity only occurs in extreme scenarios, repeated overheating over long periods. Occasionally, mindful reuse is safe. This is a great example of chemistry being neutral. It doesn't intend to harm. It just responds to heat. Aldehydes formed during repeated heating are detectable by smell. Polymerized fats make oil thicker and darker. These chemical changes affect flavor, aroma, and frying performance, not immediate health. If your oil passes the sensory test, smell, color, taste, it's safe for one more use. Reusing cooking oil is not inherently dangerous. It's a practical habit, but like everything in chemistry, it has limits. Understanding how oil changes with heat allows you to cook smarter, preserve flavor, avoid unnecessary chemical breakdown. Remember, chemistry is your ally in the kitchen, not your enemy. Pay attention, trust your senses, and your cooking will be both safe and delicious. Cooking is chemistry, but it's not scary. Every time you heat oil, saute garlic, sear meat, or reuse cooking oil, chemical changes happen. Some changes affect flavor, some affect aroma, and some produce minor compounds. But the truth is simple. Most of these changes are safe in everyday cooking. Overheating oil, just watch the smoke and match the oil to the heat. Burning garlic or onions, use lower heat or add garlic later. Overcooking meat, aim for golden brown, trim charred edges, and consider a marinade. Reusing oil, limit reuse, store it properly, and trust your senses. The common theme is awareness, not fear. Chemistry is neutral. It doesn't intend harm. It just follows the rules. When you understand these reactions, cooking becomes easier, safer, and more enjoyable. You can savor flavor, cook confidently, and make informed decisions, all without stress. So next time you're sorry in the kitchen, remember, chemistry isn't set the enemy. It sets your guide to better food.